The overall goal of this procedure is to present an experimental setup and protocol in a library environment to evaluate neurally controlled artificial legs on patients with lower limb amputations. This is accomplished by first preparing for surface EMG signal measurement from the subject's residual lower limb muscles. Then, the powered prosthetic leg on the recruited subject is aligned and calibrated. Next, the training data is collected and the classifiers in the neural machine interface are trained. The final step is to test the performance of neural control of the powered prosthetic leg on the recruited amputee subject. Ultimately, the neurally controlled powered prosthetic leg is used to allow the subject to perform various activities, such as standing, level ground walking, ramp ascent, and ramp descent safely and continuously in the laboratory.
The main advantage of this design engineering platform is that each function block can be easily debugged, modified, and updated. In addition, adding or deleting functions or changing the connection between modules can be easily done in the computer program.
The new electrode socket interface design can provide high-quality EMG signal recording, tight socket suspension, and good user comfort. Therefore, this design can be used to investigate the muscle property or function in the residual limbs of lower limb amputees. Demonstrating the procedure will be Huang, William Boatwright, and Aaron Fleming, the students from our lab.